Hey, today we're going to be learning about arc length, how to find arc length, and understanding how and why the arc length formula works. So, what is arc length? Arc length is the distance between 2 points on a curve. Here we have the graph of a function, y is equal to f of x. We want to figure out what is the distance from point A to point B on the smooth curve, also known as the arc length. What we have learned from calculus and integrals is that a line or curve can be seen as the path of a point in motion. To find the length of a smooth curve between 2 points, we can integrate an infinite amount of these points in motion. Let's call these points in motion ds, which would make the line s. More on that in a second. So, these are the infinite points in motion. Right? So all my ds's. So, like I said, that is infinite. In order for us to derive information from this, we are going to use something similar to a technique known as the Riemann sums. So what we're going to do is we're going to make an approximation of something that is actual. So we're going to make a line. Let's say I'm going to pick this particular ds, right? Just going to change my marker. So here, I'm going to pick one arbitrary point of motion, right? And this is going to be the ds that we're going to focus on. As I said, we are going to make an approximation. So that means turning this into a line. So it's an approximation because it's actually a curve. But we're going to use this to mine information. So here, I'm denoting the change in x, or the dx, in context to the ds. And here, I'm showing the dy, that is the change in y in context to ds. So, what do we have here? We have something here, a relationship that we could use, that we can exploit. And that is the Pythagorean theorem. And it is, let me use another color, a squared plus b squared is equal to c squared. So our equivalence in this particular equation would be dx squared plus dy squared is equal to ds squared. Pause.
Go.
So, we're going to leave this alone for one moment. And I want to go back to talking about what I was saying about ds. So, the infinite amount of ds's is going to give us the arc length. So in order for us to plug in for this ds, we're going to use this. So I just want to show you guys. We know that there is this relationship, this statement, but it's not very useful to us yet. So using this equation, we can mine the information out, or mine the ds out of this relationship and plug it in. Let's see how this goes. So we want to get the square root of both sides so that we can isolate or mine the ds out of here. So ds is equal to dy dx squared. So we got the square root of both sides. Now we're starting to see familiar elements in this equation we have here. And the more familiar elements that we begin to see, the more it will be useful to us. We're not totally there yet, but we're going to get there. I'll show you in a second. So, what could we do here? What I'm going to do is I'm going to pull out the dx squared from both dx squared and dy squared. Now, you might be asking, how are you going to pull out a dx squared from dy squared? There's inherently a dx squared within this dy squared, and I'll show you in a moment. Now we have something that is very familiar. We have a dx and we have a dy over dx. If you redistribute this dx squared into here, you can see that this dx will go for the 1, and this dx squared will replace the 1, and the dx squared will cancel out with the dx squared, leaving us with dy squared. So that's what I meant by there's an inherent dx squared within the dy squared. Now, let me simplify this a bit more. We know that dx squared, what is the square root of dx squared? Simple. And I pulled out the square from both the dy and the dx. Now we have something that is very, very familiar and useful to our knowledge in calculus thus far. So now let us replug this into here, because this is equal to ds. Now let's plug it in. Here we have our equation for arc length. Now, we used an approximation to get some data from our situation here. Now, what we can do is go from our approximation and go back into an actual measurement for what all the DS's are. We can integrate all the DS's infinitely. That is arc length. That's how we get it. That's how it works. Thank you.